Hello, here I would like to present the solutions for the Chapter 1 homework assignment. Chapter 1 homework starts with question 14, Q14, which asks, which of the three science fields, biology, chemistry, or physics, would you say is the most fundamental? Spoiler, this is a physics class, so hopefully you assume the answer is physics. But it also tells you to explain why. There's a lot of good answers to this question, but the answer that I would give is that those other sciences, bio and chemistry, are founded in the principles of physics. They work because of the principles of physics. Physics explains the underlying principles of the universe that allow chemistry to work, and then those chemistry principles allow biology to work. So physics is called the fundamental science. Question 15 is kind of fun. It says, based on table 1.2, which subfields of physics would you say are involved in rainbows? So, rainbows. Rainbows. And also asking which subfields of physics are involved as an acorn. I can't draw very well, but there's an acorn. Falls. So, what's involved when you see a rainbow? Well, what's happening with a rainbow is that light is scattering. Light hits droplets of water in the atmosphere and we say it's refracted, that means it's bent. And the direction of the light is changed. When it hits those droplets, it refracts in a variety of different directions and scatters, which causes the different wavelengths of light that represent the different colors to separate from the white light coming from the sun. The study of light is called optics. All right. When an acorn falls, we're talking about acceleration due to gravity. When we're studying how things move and why things move, that's the study of mechanics. I abbreviate there because it's getting close to the edge of the page, but the study of mechanics is the study of how things move and why things move. And that's what we're going to spend a lot of time at the beginning of the semester studying. The first several chapters are on mechanics. Question 16 is very similar, based on, again, table 1.2, subfields of physics explained why an ice cube melts. That's melting. All right, that's water running off of the ice cube. You just take my word for it. We'll call that A, ice cube melting, and B, explain how an airplane flies. That's an airplane, and it's flying. We'll call that B. The study of heat and temperature and the transfer of energy through thermal processes is called thermodynamics. And we are going to study thermodynamics near the end of the semester. Part B, the airplane flying, is actually, I think, most closely related to fluid mechanics, but I don't think that was one of the options in the table. Probably the best option is mechanics, again, because it's moving and accelerating, and there are forces acting on it that keep it up in the air. But if you chose a different one and gave a good explanation, that's acceptable too. But I think the answer I would have chosen was mechanics again for B. All right. Moving along, question 18. Question 18 says impulse, which we'll abbreviate with the letter I, is defined as the average force acting on an object multiplied by the time the force acts. So, if I call force F and time t, and it says that impulse is force multiplied by time, the equation is going to look something like this. It says multiplied by, so I put a multiplication symbol right in there. It asks if I equals F divided by t is an accurate representation of that expression, and obviously those two things are not the same. right? These two things are not the same. So I'd say the answer to this question is no. This equation here at the bottom is not a good representation of that relationship. Equations, math, they show relationships between quantities. So impulse is equal to force multiplied by time. That's how those three quantities are related to each other. We're going to spend a lot of time this semester working with those relationships to solve problems. All right, next, question 19. It says the distance an object travels when it starts from rest and undergoes constant acceleration is 1/2 the acceleration multiplied by the square of the time. It says invent your own symbols and express this statement in a symbolic form. I am not going to invent my own symbols, but if you did, great. I'm just going to use the standard symbols. And if we're talking about the distance something travels, we'll call that d. There's actually lots of different symbols people use for for the distance. So they can use an x. Sometimes they use an s. I'm not sure why, but for now we'll just call distance d. And we'll say that that is going to equal 1/2 is the next thing they say in the problem. 1/2 of the acceleration. So 1/2 multiplied by the acceleration a, multiplied by the square of the time. So there's the time multiplied by the time, but it's not just the time, it's the square of the time. So we have to put that little power of 2 up there. And there's your equation. And that's an equation we are going to use in this class quite a bit, especially in Chapter 2. Question 20. What are the primary advantages of the metric system over the older English system? There's a few. One, conversion. It's easy to change units in the metric system. They're all based on multiples of 10. So you have a centimeter is 1/100th of a meter, and 1/10,000th of a kilometer. It's always going to be some multiple of 10. So it's always based on powers of 10, which makes it really easy. Okay, maybe not really easy, but much easier to convert. If you're talking about the English system, you have 12 inches in 1 foot, and then 5,280 feet in 1 mile. It's not standard, right? This number, where does this come from? There's no standardization. So it's much harder to remember those conversions. It's much easier in the metric system where you have standard prefixes that are universal. And that's another thing that's nice, is that it's widely used. So it's international. Around the world, generally, they use the metric system. Even in England, they don't use the English system. They use the metric system. So that's kind of convenient. There are other possible answers to this that you could have used. These are the two big ones that I thought of when I was answering the question. All right, now into the exercises. These are mostly conversions, and we covered conversions in class, but I'll go through the solutions to these really quick. It says, suppose a pancake recipe designed to feed 3 people, so 3 people, requires 600 milliliters of flour. How many milliliters of flour would it take? So I want to know how many milliliters it'll take if I want to feed 5 people. That's a question mark, by the way. I don't know if you can tell. It's hard to write with this stylus. If I want to feed 5 people. For this one, we're setting up a ratio. If 600 milliliters gives me enough to feed 5 people, I want to know the same ratio, but for 5 people, how many milliliters? I put a question mark there. Now I could, that's not the eraser. All right, I could say X number of people. So make it a little bit more algebra-y or mathy, but it doesn't really change anything. To solve ratios, you'll think back to your high school math. you can cross multiply. 600 times 5 equals 3 times x. So I take 600 times 5 and divide it by 3 to solve for x, and I end up with x equals 1,000 milliliters. Notice I put my answer in a box there. That's kind of nice when you're submitting answers to me. It's nice to be able to find the answers easily. Alright, next, E5. It says that a woman's foot is 9 inches long. 9 inches long. And she steps off a room and finds that the room is 15 foot lengths. I'm going to write foot lengths out because a foot means something in this problem. So 15 foot lengths long. And it says, what is the length of the room in feet? That's the unit of measure, feet. And in inches. So how do we solve this problem? I know that 9 inches is equivalent to 1 foot length. And now it's just like the conversion problems we've done in class. So I'm going to multiply by some conversion factor that I want. I'm going to take 15 foot lengths, and the foot length unit will cancel itself out, and I end up with 9 times 15 inches, which is 135 inches. Now I've got to find out how many feet 135 inches is. So I'm going to draw a little line here. I'll change colors of my marker, and I have 135 inches. And I'm going to multiply by a conversion factor to get inches into feet. I know that 12 inches is equal to 1 foot. So my inches unit cancels out. 135 times 1 divided by 12 gives me 11.25 feet. So answer for inches, answer for feet. Number 7. A crate has a mass of 9.40 kilograms. 1 kilogram, kilo means 1,000, so 1 kilogram is 1,000 grams. It asks what is its mass in grams, and then what's its mass in milligrams. So we have a straightforward metric conversion. So I have 9.40 kilograms, but I want this to go to grams first. How many grams per kilogram? 1 kilogram is 1,000 grams. So I take my 9.4, the kilogram unit divides out, and I get 9,400 grams. Okay, now I could convert directly from kilograms to milligrams, but that's not as easy of a conversion. So I'm going to go from my grams unit that I just figured out. I have 9,400 grams, and I'm going to convert that to milligrams. It's a pretty common unit if you look at the food packages. You see milligrams in your food packages. It's a really, really small amount of stuff is a milligram, and I need to convert from grams. A gram is actually pretty small. If you think about the weight or the mass of a dime, it's somewhere in the vicinity of a gram. All right, so how many milligrams in 1 gram? Milli is the same metric prefix as millennium or a millipede. It's 1,000 again. A milligram is 1/1000th of a gram. So my gram unit cancels out. Multiply by 1,000 again. I get 9,400, and then 3 more zeros, and that's how many milligrams that crate is. Answer 1, answer 2. All right, last one. Exercise 12. This is one that is different between the 7th edition of the book and the 8th edition of the book. I'm actually going to give both answers because maybe I'll go back to the 7th edition at some point. The only difference between the two editions of the book is the speed limit that they give in the problem. Let me read the problem real quick. So, exercise 11 says, a common speed limit in Vancouver, British Columbia is 90 kilometers per hour. That's the speed limit in Vancouver, British Columbia. The old textbook said 80 kilometers per hour. So evidently in Vancouver, they increased the speed limit at some time between the two printings of this book. Now, in the U.S., we don't usually measure kilometers per hour. We normally measure in miles per hour. And it says if you are traveling, so if your speed or velocity is 55 miles per hour, are you speeding? It says show using the conversions in the front cover of the book. Okay, so what we need to do is convert my speed, 55 miles per hour, into kilometers per hour. How do we do that? So I'm starting with 55 miles per hour, and I eventually want to get to kilometers per hour. The hours are fine. I don't need to change the hours. What I need to change is the miles. I have to get from miles to kilometers. So how do I do that? I need a conversion factor that allows me to divide out the miles and end up with kilometers. Remember, a conversion factor is a special version of 1. So it's two things that are equal divided by each other, which gives us this 1 inside the parentheses. If you look at the front cover of your book, you can find that 1 mile is equal to 1.609 kilometers. You could also go the other way. You could find out what 1 kilometer is and find out how many miles that is. But the one I found in the front cover of the book is 1 mile is equal to 1.609 kilometers. So, inside the parentheses, those two numbers are equivalent in value even though they look different. And it allows me to divide the miles unit away. It cancels. I take my 55, I multiply by 1.609, and I end up with 88.5 kilometers per hour. Now, in the old textbook with the old speed limit, that's speeding, that's no good. But in the new textbook with the new speed limit, yay, we are not speeding. You can travel at that speed and not get pulled over. That is all of the homework this time. Hopefully you got a lot out of it, and I look forward to working with you more in class. Have a great day.